Hey all, Miss Pariseau here to talk to you about systems of equations, but dealing with the word problems. That's the more natural, well, not natural, I should say, but more likely way that we would be using these in real world. So just to show you, this is how I introduced it in class and we talked about it. So in case you missed it or want to go back and review, this is one of the problems that we started off with. So anytime you're doing these, what you want to basically, you should have a highlighter, you should have your pencil, you should be interacting with the problem. You want to really be able to write stuff down and take notes. Nothing should be kept up in your head. So, all right, so let's take a look. We got Barbie. You tell I got little girls at home. Okay, Bobby. We got Bobby here. He's charging inventory. Apparently he's bored counting bikes. So we see that there's a display of 18 bikes. So that's a piece of information. There's a total of 18 bikes. Some of them are tricycles. So we have tricycles and the rest are bicycles. Okay. Bored with counting the number, he now decided to count how many tires. So he's now counting tires and he counted 46 tires. And now here's the question that we want to make sure that we're paying attention to. How many tricycles and bicycles are there? All right, so Bobby's making our job a little difficult. Just instead of just counting the tricycles and bicycles, he's giving us a little more riddle. So let's kind of think of what we have. We have tricycles, and we have bicycles. If I'm thinking about it, that's what we have right there. And I know that there's a total of 18 altogether. All right, so I'm actually, you could use X, you could use Y. I'm going to be honest with you. I use variables that represent what they stand for because otherwise I get confused. So I'm going to use T and I'm going to use B. All right, so the number of tricycles plus the number of bicycles is going to total up 18. All right, well, that doesn't help me out. Okay, so let me put my equation off to the side. But I at least have, all right, I at least have, oh, it's a little out of focus, huh, for you guys. Okay, I at least have variables now, and I'm kind of going with my equation for that. There, okay, that's a lot better. All right, now the other thing that he told us is that we're talking about tires. So now it doesn't come out and tell us this, but he counted a total of 46 tires. Anytime we have a total, that's our end result, right? Okay, so if I think about it, I'm like, all right, well, if I have 5 tricycles, how many tires do I have? Well, a tricycle has 3. So I'm going to do 3 times the number of tricycles. That will tell me how many tires there are. And a bicycle has 2 wheels. So there's my new equation, okay? So 3 wheels, if we think about it, per tricycle. 2 wheels per bicycle. And the thing is I want you to think about, like, how do you know what kind of equations to set up? Well, look at the 2 different things they're talking about. They're talking about a total of bikes and they're talking about a total of tires. So I wrote an equation that dealt with the total amount of bicycles, tricycles. Then I did an equation for the amount of tires. So you kind of want to keep that in mind. Like, what are the 2 different ways this problem is comparing it? So now here is my system. And then you've got a set of options about how do you want to solve it. Now, we've done the elimination method. So personally, that's my favorite one. And remember, sometimes you have to send in your hired goons. You could do substitution and solve for one of these and then plug it in. But I'm going to go ahead and do elimination, and I'm going to get rid of the b's. I'm going to get rid of those b's. So instead of a positive, I'm going to multiply everything up here by -2. So now I get -2t minus 2b equals -36. So if we're thinking about it that way, my system, I rearranged equation A. I'm not doing anything to equation B. And boom, I've got my answer. Tricycles, 10. All right, always go back to the question. Make sure, and this is why it's so important, that variable that that you use, that you know what it represents, because we have to know, like, what if this just asked me how many bicycles are there, right? That's not my answer. I'd have to go back and find the other value. So you want to make sure you know what this number is standing for. So my tricycles are 10. Well, if tricycles plus bicycles is 18, that must mean, so we have 10 tricycles, because I can't spell, and 8 bicycles. Okay, and I can check that out. That would be 30 tires. That would be 16 tires. Yep, that works out. Boom. There is my final answer. Okay. All right. So let's take a look at another one. This one. Okay. Money problems are like, I don't know why people like to talk in riddles. Apparently, there's a lot of people in like math land that are like, hey, guess how much money I have in my wallet or how much coins I have in my pocket. I promise you, there are definitely real world applications with this, but this is just to kind of get you that set up. All right. Let's take a look. Pause it and see if you can set it up yourself, or if you've already watched this and done it, kind of refresh your memory. Okay. And then check back in. All right. So what I'm taking a look at is we're talking about how many, like this is like pieces of money. Pieces of money, the amount of bills that she has. But then we also have a total of like a dollar amount. So those are the two separate things. So she has in her wallet, she's got a total of 15 bills. All right, so we know that she's got a total of 15 bills. And we also know that it will total $110. So my first equation is going to be about those bills. So what does she have in her wallet that adds up to 15? Well, she has fives. She only has tens and fives. Wish I had tens and fives in my wallet. Okay, so she has, let's use F for $5 bills. And usually I don't like T's, but we're going to roll with it. We'll make it look like that. All right, she's got fives and she's got tens, and there's 15 of them. Okay, so maybe she has 3 fives, and what would that make us a 3? That'd be 12. Miss Paris can do math, yeah. Okay, so the total amount of 5 she has, so if we're thinking about it, F stands for the number of $5 bills. T is standing for the number of $10 bills. So that's what the variable stands for. All right. But now we're talking about a value. Well, it doesn't give me any other information. So we have to bring some background knowledge to this. So if I'm talking about money now, I'm trying to like, okay, well, if she had 3 fives in her wallet, how much money would that be? Well, it would be 3 times a 5, because a $5 bill is worth $5. I know, shocker. And a $10 bill is worth $10. So if this is the number of $10 bills she has, if she has 3 $10 bills, that's $30 value, right? So we got the dollar value, we have the bill value. Okay. So now we can go ahead and use our systems. What we know about systems, you can do substitution if that's your jam. Again, I told you my favorite is elimination. I like playing mama boss. And let's see, who don't I like? I like to take a little, well, you know what, multiplying by tens is easier. Let's multiply by tens. I mean, 5s aren't hard either, but. All right, so I'm going to eliminate this 10 here. I don't like the looks of them, so I'm going to multiply everything by a negative 10 up there. So I get negative 10F minus 10T equals negative 150. All right, so that's 5F. Nothing happens to the other equation. I only needed to send in one of my hired goons. And so there's my system. This is my new system. I might want to like mark that off so you don't get everything mixed up. Going to add them together. I get negative 5F. Those guys cancel out. Equals negative 40. F equals 8. All right. Go back to the question, how many of each bill does she have? So this only answers, so I have, not I, Julia. I don't have any bills in my wallet. Okay. Julia has 8 $5 bills. And so she has 8 there. That means she has 7 $10 bills. Boom, boom, boom. Okay. So that's kind of gives you an idea about how to approach these word problems. Now, these ones tend to set themselves up for, what am I trying to say? The elimination method. There are times where you've got to be on the lookout for ones that might go into slope-intercept form. So this is kind of like that standard form that we were talking about. I've got two things and they equal a total. So I've got, so that's kind of your clue there. And then if it was more of like having to set it up, remember, in the slope-intercept form, okay, that tends to be when we're comparing two different companies, or, you know, we're comparing little Bobby to little Susie, and we want to know when they will both be the same. They tend to take that format. So that's kind of like a little bit of an info there too. So remember, if you're using this format, you're going to be given one rate of change and maybe a starting point, okay? Whereas this format, you've kind of got some sort of relationship happening between two unknown things. So keep your eyes open for that and think about that as you approach your word problems. All right. Happy math solving.